Hello, I'm Recompressing, and this is the first video in a series where we'll play with everything Mega-Drive related. This is a video where we'll explore some of compression formats used in SEGA Mega-Drive games in the 90s, and a few new ones. We'll also start building a decompression benchmarking tool and do Mega-Drive programming and compare different compression formats to figure out which one is the most efficient and when. The plan is simple. We'll grab a large enough graphics set from a real game, Sonic the Hedgehog 1 in this case. We'll play with the set, recompress graphics into different formats, and compare them. For compression tools, we'll install MDCOMP. It's a modern library designed to work with compression formats used by SEGA titles. And once we compress graphics, we'll write our very own Mega-Drive ROM to decompress them. We'll be using MD library for this to handle output easily. So, let's begin. MDCOMP is a framework for compressing and decompressing some of the formats used in Mega-Drive games, most notably by SEGA itself. It was created by Flamewing, and it's a very fine piece of software as it provides the best possible compression rates. Now, let's compile and install it. Alright, here we have MDCOMP repository, which we're about to clone, using standard git clone command. Now let's see what we have here. Repository is cloned. Let's check out build instructions, cause we have ones. We need a C++ compiler, check, CMake, check, and boost. I don't remember the exact package name, but I should be able to find it. Yeah, it's liboost -dev, and I can also verify that it's properly installed. And if you don't have this installed, you can run apt install liboost dev cmake gcc, which works on Ubuntu and Debian, of course, if you use them. Now for the actual compilation, we run cmake for the initial configuration, and time to build it. And we're done. We now have a build directory with all the compiled utilities which we can explore and even run them. As you can see, we have a lot of executables there. So there's Comprex, compressor, and decompressor. There are other tools. Let's actually install them. But oops, before we do, let's go back from the build directory. And it's done. Everything is now available globally, and we can actually start using the utilities. But first, let's talk about what we have done. We got a bunch of tools, but what are those tools and what do they do? Well, these are command line tools. Each tool is named after a compression format it's responsible for. And in this video, we'll be mostly using formats used for graphics compression. Formats we'll look at today are Nemesis, Kaczynski, Kaczynski Plus, LZKN1, Compar, Compar X, and Rocket. So now that we've got the tools, we can start working with them. For the first step, we'll grab a disassembly of Sonic 1. This game is using Nemesis to compress most of its graphics. We'll decompress the graphics and recompress them into various formats. So the plan is to download Sonic 1 disassembly and practice on some of its graphics. And by downloading, I mean cloning. Let's visit a very specific directory called artnem. This one hosts Nemesis compressed graphics, and as you can see, there's a lot of them. This is because it's most used format in Sonic 1. Now let's actually, before we start, let's detox file names. And by detox I mean running the small utility which removes spaces and replaces them with dashes and underscores. This is actually crucial for scripts we're about to write. Now for the start of the show, MDCOMP utility, which basically takes two arguments and options. Let's decompress our first file then. We go with -cmp/-x for decompression, enter the first file name in the list, and the same file name with unc extension. And we get it. Now we have uncompressed file, and as you can see, it's much larger, which is insane. Alright, let's must decompress the rest of the graphics then, for which we use a simple bash, for loop in bash, and run basically the same commands, substituting file name and unc extension, except let's see what it will actually execute by adding echo. Yeah, the extension isn't quite right, but nothing we cannot fix. I personally use base name command, which I'll show you in a minute. I can remove suffix with it, and as you can see, it's much better now. So it basically takes 2 arguments, it removes suffix from the file name it gets. Now let's remove echo and actually run it. As you can see, we got a bunch of uncompressed files. But what's now? Let's create a separate directory for them. Let's call it unc, and let's move every file with unc extension to this directory, and you'll see why in a minute. Now notice the file size, 164 kilobytes, and notice uncompressed file size, 352 kilobytes. Wow, this is quite insane. Now for the interesting part. Just as we decompressed graphics, let's compress them back, and you'll see why in a minute. We'll use the same command, oh yeah, I just need to replace the initial extension. We will go with unc files now, and it's almost done. Now, in similar fashion, for every compressed file there, let's create a separate directory and move everything there. Now for the interesting part. Let's go back to the original compressed files and compare them. As you can see, every file is ever so slightly smaller, so the files that were recompressed by this utility is slightly more smaller, it's slightly more efficient, which is also really cool. And we saved whole 4 kilobytes of space, which is quite a lot if you think about all games. Alright, what's now? We've got the data, let's use it. And we start by actually creating our little project, comp, compressing comparison. And we move all the data from disassembly to this little directory, and we'll practice with some of other compression formats we have. And I would love to start with Kaczynski. I love this format. We do the usual command, not the echo, so we're not running the code yet. We just type in what will be executed without executing it. Let's try this out. It's looks okay, but I would love to create a separate directory for it, like Kaczynski. Actually, scratch that. Yeah, scratch that. Let's do everything in one go. We create a secondary loop, which will run for every utility that we need. So we have Kaczynski, we have Kaczynski Plus, we have Comper, we have ComperX, and the KN1, and I think Rocket? Yeah, this should cover all of them. And for every utility, we create a directory with the same name as the utility. Let's actually add echo command, so it's not executed, only printed. We close the secondary loop. Let's try it. Alright, looking good so far, but if we scroll down, let's see how other utilities work. Yeah, I forgot to replace utility name and extension with dynamic ones. Let's actually do that. And let's not forget about the directory. Let's create file not in the same directory but in the subdirectory with the same name as the usuyus. And it looks much better now. We have different commands. So we have Kaczynski Plus, we have Kaczynski KMP, the old one. And every new compressed file is created in a subdirectory with the same name as the utility. And I think we're ready to run this. Let's remove echo from these commands. And less, of course. And we're done. We have everything compressed into various compression formats. Let's actually move this to the root directory. And there we have it. Everything is nicely arranged. Unc hosts uncompressed graphics, and every other format is named after the utility that produced it. And it has the actual extension. Now let's see how well they compare. We've got the same data compressed with different compression algorithms, and everything is placed in separate directories corresponding to algorithm names. All we have to do now is to get the size of each directory in bytes and see how well files there were compressed. And there we have it. Now, let's get this into a nicer form. As you can see, using any form of compression has insane benefits. If you compare uncompressed data to Nemesis, the original format used in Sonic 1, it compressed to almost half of the original size. Kaczynski Plus, a newly developed format, clearly has the best compression rate. It's less than a half of the original size. But the original Kaczynski comes extremely close. LZKN 1, economy format, also comes close to Kaczynski. LZKN 2, aka Rocket, is slightly worse than Nemesis. Comper and ComperX don't impress with their compression rate, but they still saved more than 150 kilobytes of space. Maybe they can impress us with something else? We'll see. Compression rate is a great metric, but what if it takes too much time to decompress on an old CPU? This will certainly limit how fast we can load graphics in our game. So it's finally time to put the data we have to good use on the real machine. This is the part where we start building our very own Mega-Drive ROM. We'll use MD an easy-to-use wrapper for initializing hardware and printing stuff on the screen. So let's get straight to the point. So we'll be using MD Shell as a base for our little project. So let's get this going. We copy the link with this nice demo of MD Shell. Let's actually download it and unzip it. Let's remove zip file so it won't get in our way. Let's check out the code, which is a small hello world and a small demo of other stuff that it can do. And in readme it says to run build bat. To compile it, we shall do through line since I'm in Linux. And we get rom.gen as an output, which we can run. I'll be using blasttemp here. And here we have it, a small hello world. But let's actually port build script to Linux because it's much more convenient for me. It's quick. I will just replace bash syntax, batch syntax as bash, and add a call to run our ROM for convenience. And let's add executable flag so we can run it. And let's run it. Okay, we need to fix line endings to be Unix style. That should do it. And there we go. Hello world compiled, automatically run. And let's actually remove this, we won't need anything like it from now on. And there we have it. a clean slate for our new project. Let's get started. Let's start with a tiny cleanup. Let's create a data directory and move all actual compressed data there. So it's nicely arranged now, and well, here let's also remove the old build script because we won't need it. And let's create directory which will host the compressors. Actually, I got the name wrong, it should be the comp. And now, since we're there, let's find the original Nemesis decompression in Sonic 1 disassembly. Should be, yeah, right here. And we have a Nemesis decompressor now. Let's rename it to just Nemesis for convenience. Let's actually look at its code. We don't care about its code much as long as it works. So let's try to actually compile it. Now we include this code. It's in MDCOMP folder, and as the file name is Nemesis. Try to build it. Oops, sorry, wrong directory. Build it again, and it failed. So we're missing a few constants for the VDP data port. This is suspiciously RAM related, so this one decompresses to VRAM. We don't need this routine, we only need to decompress to memory. And finally, Nemesis uses additional buffer. Let's just assign it some memory address so it will shut up. And let's try it again. Alright, it's all done, we compiled the code. Now what? Now let's actually go and find some data that we can decompress. I think I will go with hot file. Where is it? Hot. Yeah, it's a nice file and it's easily readable. So we'll just encode it. nem_hot, and we use incbinf means, which means include binary data. So it's not code, it's actually binary data, and it's located in data folder. And it's there. It compiles. Now actually let's copy this function signature and try to call it to decompress this data. Now we need to define a start address for the arts that we need to decompress in register 0 and destination address in register 4. We'll use just RAM. And we call this routine. And boom, it works. Or does it work? Can't really tell, maybe it's frozen, but at least it doesn't crash. Let's actually move this console line there and do all done message. Alright, it's all done, we're good. But it's a bit underwhelming, don't you think? How about we see what's actually decompressed? Can we tell we did it right? You know what time it is. It's Hex Viewer time. Now let's actually find data for comparison. We have compressed hot, we have uncompressed hot, which is located in unc directory. Which is obviously the same data but uncompressed. As you can see, it has so much nicer form and much longer file. And let's actually write a Hex Viewer function. So what we need to do is to visualize what we decompressed and make sure it matches what the decompressed file holds. And let's use A0 register as initial address that we will view from. This is the same address we actually decompress this data to. Now let's see, let's start with just type in the address that we got. Let's start there and see where it gets us. Okay, address and colon. That should do it. Alright, this is nice. Address is correct. Now what? Now let's display the data on this address. And we display a long word which is 4 bytes. And there we have it, 4 bytes. Actually, yeah, this matches, but they're just a bunch of zeros, so nothing much. Let's display the second long word. And we have a first glimpse of data. And it matches what we have in the original file, which is great. Now, let's actually display more than a single line. Let's do the next pair of addresses. We increase by 8 bytes. This is because this is how much we displayed. And there you have it, 2 lines. Nice. But this is still not much. Let's, instead of copy-pasting code, let's do actual loops. Maybe 20 lines, 20 iterations will do. Yeah, this is much better. I can see more data now, more precious data. But this is non-interactive. Let's add some interactivity maybe. Maybe make it a little bit more scrollable so we can see more lines. Let's go with console.pause, which will wait for us to press any button on the joypad, and we branch back to the beginning, so we repeat the cycle. Now we press, we see more lines, but they are rendered after the last one. Let's actually clear the console, so we reset the whole screen. It's much nicer now, we can actually fully scroll, but I don't like this flickering. This is because this is an expensive operation, it takes time. But since we don't redraw much, let's use console set XY to reset position instead of clearing the screen. And look at that, it's much nicer now. Alright, now what? Let's actually do more lines to fill the whole screen and add some color. I think it should be PAL 2 and PAL 0. And there we have it. A nice functional Hex Viewer with one button to control it. Now let's compare data we decompressed to RAM to the original uncompressed graphics. And I'll be using a Hex Editor plugin I have. And what I want to do is to get it to look the same as in our little ROM. So I changed it to group every 4 bytes, as you can see. Now let's actually change how many bytes per line we have. And we need to set it to 8. This is exactly what we have in our little ROM. And let's compare. Now we run a ROM and let's just put this side by side. And it's a complete match. It matches line by line, so we decompressed all the data correctly. Let's stop for a moment and talk about what we have done. We've compiled MDCOMP, a set of compression utilities. We extracted Nemesis compressed graphics from Sonic 1 and recompressed them to other formats. We've compared these formats by compressed data size. Finally, we created our small Mega-Drive ROM where we imported Nemesis decompressor from Sonic 1 and decompressed our first file. And then we made sure data we decompressed so far is correct. But we still have a lot ahead of us. We need to import the compression code for other formats. We need to decompress other files. And most importantly, we need to measure how long different formats take to decompress. So this is only the beginning of our journey.